Good morning, everybody. Today we're going to be talking about sine and cosine and their graphs, and primarily talking about transforming their graphs. So finding the amplitude and the period of your sine and cosine function. So not too many notes today, just these two pieces of information. So if you recall from last trimester, we had transforming functions by multiplying inside and outside of functions. So the outside, we talked about a vertical stretch. In trig, we call this the amplitude because it stretches. Normally the amplitude's 1, so that vertical stretch is just going to relate back to what's called an amplitude. I'll get a little bit more into that in a second. The other type of multiplication that happens is inside of parentheses. This is what is the the horizontal stretch or compression. Remember, that's a little bit backwards. It's an inverse relationship or a reciprocal relationship. And we use omega for this. And omega is, we correlate it with what's called the period. The period is the amount of time it takes for sine and cosine to start repeating itself again. This is true for all of the trig functions. The amplitude is the positive version of A, so always take the absolute value of it. It should never be negative. The period is 2 pi divided by omega. The normal period is 2 pi for sine and cosine. For tangent, it's pi, so we'll get into that more tomorrow. But to find the new period for the transformed sine or cosine, you're going to take 2 pi and divide by omega, not multiply. Omega should just be the number of full cycles that you can fit in the normal period. So I should be able to fit omega cycles within 2 pi. If omega is 1, it doesn't change. It doesn't compress at all. So it'd be 2 pi divided by 1. I should be able to fit 2 pi, or I should be able to fit 1 cycle within 2 pi if omega is 1. So things like that. Just a quick refresher, sine functions look like this. This is your amplitude, so the distance between the midline, or the halfway point between the two peaks. The distance between the midline and a peak, or the midline and a minimum, is your amplitude. And then this distance, so start of a cycle, end of a cycle. Use these little markers to figure out what that is, but this is the period, so the distance it takes to complete a full cycle. So if you needed to add that, feel free. But getting into the questions, finding the amplitude and the period of this. The amplitude is the absolute value of that coefficient, so absolute value of -2 is 2. This is our amplitude. And then this is omega. Omega applies to the period. A period is equal to 2 pi over omega, which is 4. 2/4 simplifies to 1/2, so this is the same thing as pi over 2. And it is as quick as that. Okay, so the nice part about this is you don't have to do much plugging in. You just have to think about sine and cosine and then transform it based off of these things. But before graphing, always figure out these values. So you always want to figure out what the amplitude is. And in this case is the absolute value of -4, which is 4. And then the period is 2 pi divided by omega. So 2 pi divided by pi is 2. And I tend to spread mine out a little bit more than this, so you might divide this in half and have divided by 8 and have those be your horizontal units. Since it's already written here, I'm going to do that. It just means you can fit more cycles. But divide your period by 4, and this is kind of a clue as to what you should label or what you should scale your x-axis at. I mentioned this, but You can also divide it into eighths and then have that. It'll spread it out a little bit more, but it doesn't hurt to have more cycles. The x-axis scale should be 1/2. Or let's do 1/4. I'm going to divide that by 2 again, so 1/4. So I'm going to call this 1/2. This is 1. And then these are all going to be fourths. So I can fit one full cycle within 2. So from 0 to 2, it should just be one full cycle from 0 to 2. And then I tried to make my amplitude this position. So this is 4, this is -4. You could squish it or you could stretch it a little bit more if you needed to, but this is where I would go with. And then we're dealing with cosine. So cosine starts at air quotes 1, should start now at 4, which is the amplitude. And then it starts going down, and then every quarter it's going to intersect with either 1, 0, or -1. So every quarter, or in this case a half, you're going to be hitting either an axis or minimum or maximum. So looking at these. So one full cycle looks something like this. Draw a couple in there, but again, every 2. And notice that I'm not plugging anything in. The only thing I'm looking at is the starting position and then how far I need to go to get to each of these points. So I'm not plugging too many coordinates in, but still very quick to graph these once you have the groundwork made. Same idea for sine. This time it wants you to make one. There are technically 2 answers to this without any horizontal vertical shifts. There's either 2 as your coefficient or your a value, or -2 as your a value. Just to keep things simple, I'm going to make it +2. And then we have a little work to do with the period. The period is equal to 2 pi divided by omega, omega being the coefficient inside of the function. So if you solve for omega, basically multiply and then divide by 4, you get that omega is 2 pi over 4 or pi over 2 if you simplify. So pi over 2 is our value in there. So here's our function. Our period's 4. If we divide that into quarters, quarters would be 1. Our x-axis scale is going to be half of that, or 1/2. And that just makes it so you can spread it out a little bit. So these are our quarters of our period. And these are counting by ones. So we should be able to fit a full cycle within 4. And that should check out because we said the period's 4. Sine starts at 0, 0. That shouldn't change even if you scale it. I put the amplitude again there and there. So our amplitude's 2. This just makes it so you don't have to scale on your graph too much. So this is where we had a peak or a valley or x-axis. In this case, we're starting going up, then back down. So we have this going on. That's our next important point. I'm going to make these hash marks instead. But it just keeps following that pattern. Two-way, two-way, two-way. It's really important that you're careful when you're doing this, because if you mess up on one, you're going to mess up on everything else after that, just because you're basing it off of the graph and not calculations. So make sure that I think all of these end up really nicely. Either it's going to end at 1, -1, or 0 at the ends of these graphs, so just good check. Okay, next. First, it wants us to create an equation out of this. So when I'm doing this, there's 3 things I look for. There's, is it sine or cosine? And really it doesn't matter, well, Today it's going to matter, but in the future it doesn't matter between sine or cosine. You just kind of have to pick. I try to pick the one that has the same starting point that I'm at. Sometimes you don't have that luxury, but this one starts at 0, 0. So I know it's going to be sine if I don't want to do a horizontal shift or if there's no vertical shift. If it started out at our amplitude, we would say it's cosine or opposite of that. But since it's starting at 0, 0, you know it's sine, unless you want to incorporate a horizontal shift. But we will get more into horizontal shifts at a different time. Next thing, you want to find the amplitude and then the period. Amplitudes, you just need to find that center line, which, since we didn't move up or down, is the x-axis. And then the distance away from the x-axis to either a peak or a maximum or a minimum is our amplitude. So this is A or this is A, that distance from 0 to 5, that's a distance of 5. Amplitude's 5. The period is the distance from one marker to another that's similar. So where does it repeat itself? And in this case, we're right here. So that's one full cycle. And it's kind of, and right here it says it's pi. So 2 marks is pi. This would be 2 pi, 3 pi, 4 pi. So period is 4 pi. So start putting it all together. Y is equal to 5 sine of something times x. We don't know. It's not just plugging that number in here. We have to solve for omega. And you might see a pattern already, but omega is 2 pi divided by the period, or the period is equal to 2 pi divided by omega. You can do either way. But this is 2 pi over 4 pi. Pi's cancel. 2/4 is 1/2. So omega is 1/2. And there you go. All of these graphs are in radian mode. You can still graph them using degrees, but if you want to check your work, make sure your calculator is in radian mode. I'm going to save you from me doing that, but that's all I have for you on this one. Make sure you stop by office hours if you had any questions.